In this DeBacco University video, I'll be describing what resonance structures are, when to use them, and some key features. This all hinges on the dependence of your knowledge of Lewis diagrams, because this is going to take that another step further. All right, as promised, what are resonance structures? Well, there are multiple valid Lewis structures for a molecule or ion that differ only in the placement of electrons and not the atoms. This is aided to explain the molecular stability, such as benzene's unexpected inertness, and it predicts bond lengths and strengths more accurately. So we're looking at the resonance structure 1 and 2 for this molecule. We can see how this double bond is essentially flipping from one side to the other, creating a negative charge on the right side versus a negative charge on the left side here. Again, it's different only in the placement of those electrons, but not the physical atoms. So when do we use resonance structures? Well, they're used when a single Lewis structure cannot accurately represent the true electron distribution. The actual molecule is a resonance hybrid, which is an average of all of the resonance structures. And here we see carbon with 3 oxygens bound to it. We can see our 3 different possibilities of where does that double bond occur. Does it occur on the top or the left or the right? Well, those are resonance structures, because that double bond might be flipping and those electrons bonding might be changing within that molecule. So where one single Lewis structure cannot accurately represent the distribution, this resonant hybrid or average of all these is what we would use to show the true form of the molecule. And they're shown in different colors here to make it a little easier to distinguish exactly where that double bond is occurring between those electrons. And what are some key features here and some other examples as well? Well, double-headed arrows you're used to connect resonance structures, as we can see here, because it's showing it's going from potentially one to the other. Delocalized electrons are spread across multiple atoms, increasing the stability. Bond lengths in the real molecule are often intermediate between single and double bonds, as we can see indicated here. And sometimes there's 2 structures, sometimes there's 3, but those double arrows mean that they're flipping essentially between those, and those are all examples here of resonance structures. You can see why understanding Lewis dot structures allows you to understand the slightly more complicatedness as those molecules are trying to increase stability, so you can hopefully picture what's going on the subatomic level.